Uh, web scraping, otherwise known as how much web can a web scraper scrape if a web scraper could scrape the web. Say that 5 times fast. I don't think I can. Anyways, today we are going to learn how much web scraper can scrape if a web scraper can scrape the web, and we're going to scrape the web. So we're going to learn, a little bit about what web scraping is, how to do it legally and ethically, and then we're going to learn how to do it. And we're going to check out some stocks data, otherwise known as stonks, as the kids say these days. Who am I? I'm Legality. I'm a 5th year here, double majoring in music and data analytics, and BDA education director. I'm a certified art studio instructor, but most importantly, this week's question is Netflix or YouTube? My vote is YouTube, though I do enjoy both. And my recommendation for you all is the YouTube channel of Nathaniel Drew. He's got a lot of cool videos out there about like mental clarity, intentionality, and self-development. And anyways, I find his channel very interesting and mentally stimulating. Okay, so what is web scraping? Most of you probably have a general idea, but just in case, it's also called screen scraping, web data extraction, or web harvesting. There's a lot of different names for it, and it is closely related to web crawling. But it's basically just copying whatever's on the web and storing it for later use. Things that we might want to use that data for, competitor monitoring. If you want to check, you're in a business and you want to check out your competitors and see what they're doing. You can also use it for getting data to train machine learning models. So like, for example, of our How the Duck Can a Machine Learn workshop, when we got all those pictures of ducks, well, we never asked where we got the ducks from, but one place that we could get them from is from scraping the web. And also for sentiment analysis, opinion mining, etc., especially like on Twitter or review sites, what are people saying about the presidential debate, getting sentiment analysis there. Or how are people reviewing these gummy bears on Amazon? Also for like data aggregation or dashboard creation, because when you web scrape, you can pull from a bunch of different places and then compile it all into one centralized place. And search engines also use web scraping to index the web. So one thing that you'll come across quickly if you're looking into web scraping is web scraping legal? There's actually a long history of court cases in the United States and other countries about web scraping. And I should say, disclaimer, I cannot actually give legal advice since I'm not a lawyer, but generally speaking, is web scraping legal? Well, it depends. Many websites' terms of service ban it unless you have their permission. And there was actually a court case very recently of LinkedIn versus HIQ. And HIQ was scraping public LinkedIn profiles and using that data as part of their business model. And HIQ actually won the court case. So it seems like web scraping is becoming more and more legal, even if the terms of service ban it. However, I would recommend personally that you only scrape sites where the terms of service do not ban it. And another thing to note is that the robots.txt might ban it, and we'll talk about what that is in a second. And the data could be copyrighted. Maybe it's private or it's public. What are you doing with the data later? And that's not necessarily related to the legality of web scraping itself, because sometimes it can be perfectly legal to scrape the web data, but then you can do something illegal with the data that you scraped. And then there's also the difference of legality versus ethics. You know, web scraping can put a heavy load on a site. If you're going and visiting all of their pages and scraping all of this data from their site, that can put a lot of load on their servers. So it's best to not do that. And it's also just important to use data for good. So generally speaking, though, web scraping is legal if the terms of service does not ban it and you follow the rules of robots.txt. So, like I just said, but what is robots.txt? Well, you can find it at almost any site. And depending on what it says, tells you where you can go and where you can scrape. So for example, let's do apple.com. Never looked at this one before. All right, so for apple.com, there's actually a lot of things happening here. But the important thing is that we look at this part because it's the part that refers to us because we are the star user agent. There are other user agents that refers to like the Baidu spider, which is another search engine, another different spider, another spider, another spider. And yeah, it actually looks like they don't particularly like these spiders since they're blocking a lot of their pages. But it looks like for us, for Apple, according to their robots.txt, we can go anywhere except for these directories. And this is kind of a more complicated example. So I'll actually go to our example for tonight, CNN. And so this just allows a bunch of sort of random URLs. So like CNN/AOL, I'm not sure what that would be about. Or CNN.com/beta. You know, obviously they don't want people looking at their beta page or scraping data from that. Or apparently they're Nokia. There's actually some really interesting things that you can find if you look at the robots.txt page. A more simpler example would be OSU's robot.txt. According to OSU, you can scrape, according to their robots.txt, you can scrape any part of their website except for this one PDF titled investigation report. Anyways. So we see here that if the user agent star and there's nothing that's disallowing us, then we can scrape the whole website. Or if it says disallow / that's referring to their whole website directory, can't scrape any of that per their robots.txt. Most things fall under this partial access like we just saw. So we wouldn't be able to look in that folder or look at that file. And by look at, I mean, you could go to the web page and see it, but as a scrape, you should not send your scraper there. There's also some other things that you may see from time to time in a robots.txt file, like crawl rate limiting or visit time. And these are just instructions saying, hey, wait 11 seconds between each page that you crawl, or please only visit and crawl during these hours. So to scrape a website, though, we need to understand a little bit about the anatomy of a website. And most websites are a combination of HTML, CSS, and JavaScript. So if we look at this Ferris Bueller Day Off IMBD page, we see that this is the underlying code or script behind it. And for example, if we look here, you can use Chrome Inspector to see all of this stuff. And one way that you can get to it is right click and then click inspect. And you can see that we have all of this code here, and we see most of this is the HTML. And then there's some stuff over to the side here relating to the CSS. And if you're not familiar with HTML and CSS, HTML is sort of basically the skeleton of the website and where all the data is for the most part. And then the CSS is what makes the website look good. It's all the styling behind it. And content page can be generated statically or dynamically. In this workshop, we're only really going to look at the case of static content because it's a lot easier to parse out of an HTML file. There are other ways to handle dynamic content, which dynamic content is generated when the user visits a page. There's definitely ways to handle that with web scraping. It's just a little more complicated and we won't have time to get to it tonight. So there's two great ways if you ask me, to inspect a site and see what's happening. There's with Google Chrome, like I just showed you here. And there's also with Selector Gadget. And if you click on this link, it will take you to the Google extension Chrome Web Store, whatever. And you can add it to Chrome. I already have it. And it should pop up here for use. And yeah, so I'll show you how to use that. So if we're on this page and we want to know what's happening for the code here that says Apple Incorporated, we can right click and inspect this particular element, and the Google Chrome inspector will come up here, and we see that it's this in this span tag with title Apple and class equal to column stock name, and we see here the actual text Apple Inc. And if we wanted, well, actually I'll get to that. No, I'll do that. If we wanted to copy exactly where this is in the code, we can right click and do copy, and then click on copy selector. And then I'll just paste that here if you'll see. So we get all of this from that, which tells us exactly where that text is and all of that code. So doing it by selector gadget, we click on the selector gadget icon, and it pops this little thing down here up, and I can click on Apple, and it says .stock-name. Except for these yellow highlights, it's automatically selecting all of these stocks actually, because they're all in these .stock-name class. So if we wanted all of these, great. But if we didn't, then we could click on it again to exclude it. So now we only get what's in this green here. And we see that we now are sort of indexing on this stock name and only getting the first child of it here. And you'll notice, copying again from what I had copied from Google Chrome Inspector, it gets you a little bit, it's a little bit different. Sometimes Inspector Gadget works better, sometimes Google Chrome Inspect works better. It just kind of depends on exactly the part of the website you're trying to get. Generally speaking, Inspector Gadget is better at grabbing text like this, and especially if you want to grab multiple things of text like this. And then generally speaking, Chrome Inspection is a little bit better if you want to grab a table or something like that. But we'll get to that in a little bit more concrete detail in a bit here. So just to go over the web scraping steps, generally, you gotta check the legality, and you wanna inspect the web page to see if the content is static or dynamic, because that's gonna depend how you scrape it. And then assuming static for this workshop, we'll use the rvest library. And then what you'll do is you'll fetch the web page with that library and you'll go through and parse the HTML. And then sometimes almost always you'll have to do some sort of post-processing steps because the data that you get isn't going to be exactly in the format that you really want it in. So yeah, and then sometimes you'll repeat this process, especially if you're gathering multiple web pages and parsing multiple things. And we'll see that an example of that here. So today we're gonna grab some of these stock data, and I can't remember if there's a link or not already, so I'm just gonna send that in there. We're gonna grab stock data from here, and so if you'll remember, we wanna check our terms of service. So I'm gonna Google CNN terms of service, terms of use. I'm just looking for scraping and it's not there, which is really good. So it means we can do it. For example, Twitter terms of service. Twitter terms of service, if you look for scraping, scraping the service is without a prior consent of Twitter is expressly prohibited. So there's an example of what you want to look out for. And then we're also cnn.com, robots.txt, checking that there. And what we want to scrape from is under the quote folder. And so if we look for quote, it's not in the disallow, so we're good. We already looked at the web page. We saw it was most. Yeah, so rvest. It's a R library to, or I guess I should say harvest, since it's a pun on harvest. It's a web scraping library. If you've done web scraping in Python, it is inspired by Beautiful Soup, so you may see some similarities there. And this is just the documentation page for it. So let's actually start scraping. So if you go to this link, you can sign in or create an account, get into this web scraping project, and pull up just our starter code for tonight. And I will do that here as well with you. Okay, so join space, looking at projects. Opening up the web scraping project. And it's gonna take a minute to deploy the project. Just be patient. If you refresh, it starts all over. So yeah. And Troy, in response to your question about the Bulldogs, yeah, I made that email when I was 12. I mean, you know. This is my backup email because I actually created it on the email I actually use. Okay, so after it's loaded, you can click on webscraping.rmd and you'll see our starter code here. So we start off by importing our libraries, which is rvest for web scraping and tidyverse for a bunch of data manipulation things. And then I have this sort of long function here that I made, or a couple different functions really. Don't worry about these too much. This is actually what I did. We're going to use this later to clean up a table that we're going to scrape. Okay. So I'm going to go to the financials tab because, you know, this is data. We want the numbers, right? So let's say I want to scrape this number right here, 231.3 billion. One way I can do this is I can click on selector gadget. I'm gonna select it there, but I'm actually getting all of these too. So I'm gonna click off on these. Okay, so now the only thing in green is this 23.1 billion. All right, so I'm gonna copy this selector because we're gonna use this later. All right, so now that I have my selector, I'm gonna go, ooh. Oh wait, that was the wrong code window, sorry. All right, so I'm gonna go here. And I'm just gonna make a string for this, just to go ahead and save it. I'm just gonna call it selector. It's the CSS selector. Now, I also need the URL of the page. So I'm gonna define URL and I'm gonna just copy the URL and paste it inside quotes so that it's a string according to our syntax. And then now we're gonna use the power of the rvest library. So if you look at the documentation for rvest, you see it usually starts off with read HTML and the URL. So let's see what happens there. We're going to do read HTML and URL. Just give it our URL. And if we run that, we'll see it runs the first chunk automatically for us. And we get this output here. It's an HTML document. And it's just all of this, and it's just so much that it's like ... It puts all of the head tag in this first line, and it puts all of the body tag in the second one, and it goes on for a really long time because if you remember from when we looked and inspected this web page earlier, there was a lot of there was a lot going on here, and that was just with the tags not even expanded out. So now returns to the question, what do we do with this? Well, thankfully, rvest gives us a way to deal with that. So we want to pick this value out of all of this HTML. So what we're actually going to do is we're going to pipe this into a function from rvest called HTML node. And HTML node we can actually search in the help here to see what this does. And it selects the nodes from an HTML document. And it takes the argument of the HTML document and then the CSS node. And the XPath is an optional thing. So this pipe actually throws this into the first argument of HTML node. So this is equivalent to writing HTML node read HTML URL. But it's a lot prettier, and it allows us to see the direction that things are going in. So we'll use this notation for tonight. So we're going to read the HTML from this URL, and then we're going to take that and we're going to give it to this HTML node function, in which we want to give it our CSS selector that we already defined earlier when we looked at it. And if we run this, we'll see that we get this HTML node, and we see the table that it's in this table data form, and the class is period data. But that's not really what we're looking for. It's the node, but we want the text. So what we'll actually do here is pipe it into another rvest function, which is HTML text. And so we see that we can extract attributes, text, and tag from the HTML node. So by saying text, we'll just extract the text. And now finally, we get our number here, which is super. Now, what if we wanted to select multiple nodes though? Well, let's try that. So if we go back to this page and we use selector gadget, we can select and maybe, yeah, let's just look at all of these nodes, see what happens. So we see that here, it's just period data. So if we copy that, and then we'll make a new code block. We want our code block. We'll call it new selector so we don't break our streak of non-descriptive variable names. And we're going to say read HTML. So we're going to read this URL. And we're going to say HTML node. And we're going to do with our new selector. And then we want to see the text. So it's going to run, and we only get 23 this again. And that's because I actually use the old function. HTML node. So there's actually another function, HTML nodes, and we get actually a lot. Now we get all of those values from that table. And so that's great. We get all those values, but actually this, if we look here, we actually see that, this is a very structured, this is actually pretty structured data. If you're familiar with HTML, you would likely suspect that it's in a table. And if you go and inspect, you'll actually see that there is a table. And so this is the part of why I say inspecting with Chrome is a little bit easier to get a table. And so we see here that the table class is equal to this and everything. And so we can actually copy selector. So right click, copy selector. And if we go, oops, make it bigger again. If we insert a new R code chunk, we can make a new variable, call it table selector, put it in quotes, and here's our selector for the table. And also, just in case you're a little bit behind, no worries. I'm just gonna send the code in the chat, just in case I'm going too fast. So we can actually take advantage here of something which is HTML table. And so rvest actually has a way of taking this structured data in the HTML table into a data frame, which is pretty awesome. So what we'll do is we'll read the HTML from the URL. We're going to do our one HTML node with our table selector, because we just want to select this table node. And if we run this, we see that we get all of this. It's selected the HTML code for just the table out. So we see this table class that we saw when we were inspecting the page. And then we see the head for the table and everything in the body of the table. And so fortunately with rvest, we can use this HTML table function. And we don't have to supply the X argument because we are supplying it with the pipe. Okay, and so it says table has inconsistent number of columns. Do you want fill equal to true? Well, probably. So if it has an inconsistent number of columns, it is reading something a little bit off here. Okay, so now we see this table, which is pretty cool. And actually, I'm going to save that here as a variable. So we're just going to call it df, short for data frame. And you should see it in your environment here. I'm just going to copy and paste this code again. And so you should see in your environment here this df. And if you click on it, it'll actually open it up here. And so this is kind of, it's a little sloppy, you know, but fortunately, if you know enough from the tidyverse and everything, it's actually, it's not the hardest thing to clean up. It does take some time and a bit of experimentation. So you're lucky day because I did this earlier. So I wrote these functions out earlier to clean up this table. And I tried to comment it so that if you want to go back and see how I did it, you can kind of figure it out. And we may do a workshop later in the semester of how to do things like that. But I wanted to focus on web scraping for tonight. So we can actually run this function I made, the tidy income statement data frame function, on our data frame. Oh, and I forgot to mention, in this function here, when it's defined, we see that it requires 2 arguments here, the data frame and the ticker. And so let's see, what ticker did we do? Was this for Apple? Yeah, so our ticker is AAPL. So I'll give it our data frame and our ticker AAPL. And so if we run that, now we actually see we have a completely different looking data frame. And I'm actually going to save this as our, say, tidy data frame and run that. So if we click on this in our environment panel here, we see that we have a very nice looking data frame, and it's actually broken out by the years here. If you remember from our thing here, we had the years here, and we had all of these categories. And so we've actually got this data in a much more tabular and tidy format, so that if we were to throw this into an Excel spreadsheet, or we wanted to use ggplot, make some graphs on it, or throw it into Tableau, it's actually going to be pretty easy to just take this data and throw it into there like that. And so throw this code block in there. So now we really get to the fun stuff. And by fun stuff, I mean in approximately 7 or 8 minutes, I will show you how to really take this up to the next level. And by that, you know, this is great that we have it for this one Apple stock, but you know, data in a vacuum isn't as useful as data when it's out in the data for the whole world. And so actually, we're gonna do this a bunch. And we want, there's data for all these different stock tickers out there, and we have the ability to go and get it pretty simply, reasonably speaking. We've done most of the hard work already. We just have to do this again and again and again. So we just have to put it in a loop. But we do need to remember when we run this loop that we need to wait in between each stock ticker, each parsing or grabbing of the HTML, because if we just let it go really quickly, we might put too much load on the servers, and that would not be a good scraping practice. So I'm actually gonna, for now, we'll just do it on these 3 tickers here. And what we need to do also is, so we want to run a for loop. So in R, you can do a for each loop, and you can just say for ticker and tickers, something like that. It can be for anything you want to call it in the vector that you want to run it on. So it could be X, could be, I'm going to go with ticker because I think that makes more sense. So for each of these tickers and our tickers vector here. And we're going to be proactive here. we're gonna print ticker, and if we just run this loop, we see, yep, it's going through this and printing out each of these, right? So every time we change tickers, we have to grab a different page. So that changes our URL every time, which means we need to go back and look to see, and actually if we look in this URL, we see that the symbol is in the URL. And so actually if we change the symbol equal to C, we'll get Citigroup. And if we change the symbol equal to GE, we should get, yep, General Electric. So this is a really nice feature of this website, because it means that we can just change the URL to be based on the ticker. Don't mind the train. And so one way that we can do this is actually with, wow, that's really loud, isn't it? Okay, it's probably done honking. All right, so one way that we can just change the stock ticker every time is to just sort of peel open that string and add ticker in it every time. And so that you can do that with the paste 0 function. And so what this does, it just concatenates these strings together to get us our URL. And so just to test that, we can also print our URL. And yeah, these URLs look good. We could also copy and paste into our browser if we wanted to test. So now we want to get our data frame each time. And so if you remember, we're going to take our URL. We're going to pipe it into the read HTML function, just like before. And we're going to do we can actually just copy from earlier, really, because we're going to get the HTML node with our table selector and our table. And so we'll have our data frame here. And then we want to tidy our data frame like we did before. So we're going to call it, we'll call it tidy data frame 2. And we'll do so, you know, just like we did earlier, we made this tidy data frame. We're going to run this function. We're going to run it on our data frame. And we're going to, instead of defining our ticker like that, we can actually just say, just put it like, we can just use our ticker variable since we know it's set to the string value of our ticker. And one other, we need to remember to sleep. Sleep is always good, right? But we have to make sure that we time it. And we're just going to wait 5 seconds in between each scrape. And one other thing that we need to know, though, is if we want to add all these data frames together, just stack them all on top of each other, we need to have a blank data frame that starts off with the right column headers. One way we can do this is just with this. If you want to know how I know that, it's because I Googled how to do that. And that's how you program. But so we're going to for the sake of time, also just copy this over. So what we're doing here is we're, actually I should, yeah, I should use the right variable names, be consistent. Okay, so what we're gonna do here is we're gonna drop any columns that happen to be in this secondary data frame if they're not already in our big data frame, our overall data frame, because we're only interested in the columns that we got from our original one, and it will error if we don't do this. And then we're gonna take and we're gonna add our tidy data frame to our big data frame. And let's see, let's run it and try it there. And it's going to take a minute because we are waiting 5 seconds in between every scrape. All right, it looks like it's finished. And if we look, we have our big data frame here. So we have our Apple's data, our Citigroup data, and our General Electric data. And some of the values are NA, which means that it didn't have it. But most of the values we get, and it's in this nice, tidy format. And we could do this for a bunch of stocks and get a really, really big table, and all we'd have to do is keep adding on to these tickers here. So I realized I rushed through that example for the sake of time, but I hope that makes sense, everybody. That's the last code block in the chat. A couple other things to note. APIs are also a really common way to get data from the web. There's pros and cons to them, but generally speaking, they have the same goal as web scraping because you just want to get the data, but APIs can also interact with the system. Usually, base level of how APIs work is you register with a service, like say Twitter, they have an API, and you can make calls out to that Twitter API and they will give you back a response, which is probably one reason why they ban web scraping, because they actually provide a pretty nice API. So you can essentially scrape Twitter through their API without causing a heavier load on their servers. And because it's so standardized like this, the formatting is usually easier. And if an API is provided, it's usually legal, regardless of whether or not scraping is. And it's easier when you want to make calls to the system and interact with it. But not all websites or services have APIs because that's something that they actually have to go through and put together. So it's extra effort. And sometimes the data isn't current on them because APIs really aren't a priority for most companies. And they can also have rate limits, say like 2,000 calls an hour. Here's a couple more sites to practice. These I've checked their robots.txt and their terms of service, so should be good to go on that there. And I'll send this link list out in the RStats learning channel after. So that's the conclusion of this workshop tonight. There is a feedback survey, which I would really appreciate if you went to and filled out.